Assalamu guys, Irfan back again with another video, and in this video we will be looking at one of the most popular integrated circuits called the 555 timer. So let's get started. The 555 timer is an integrated circuit or IC that has many applications. It's very cheap to purchase, and also together with its ease of use, the 555 timer IC is widely used in electronic circuits even today. By the way, it has been around since the early 70s. Now, there's also a variant of the 555 timer, which is called the 556. This is basically two independent 555 chips built into one package. So now let's discuss the pinout of the 555 timer. Now, if you notice, there is a small circle, a notch right next to the one. That's where you start counting, and you count down. It's usually on the left hand side if you're looking at from the chip from the above, and the first top left pin is pin number 1, and the one below that is pin number 2, 3, and 4. And then if you move to the right hand side, the bottom right is 5, and then 6, 7, and 8 as you move upwards. So that's the pin numbers of the 555 timer. And so now let's look at what each of those pins do. Pin number 1 connects the 555 timer IC to the ground rail. Now, pin number 2 is called the trigger pin. Now, this trigger is an active low trigger, which basically means is that the timer gets triggered or starts when the voltage on pin number 2 drops to below 1/3 of the supply voltage. Now, when the 555 is triggered via the pin number 2, the output on pin number 3 goes high. Now, pin number 3 is the output pin. Now, please note that the 555 timer's output is digital in nature, which basically means it's either high or low. Okay. Now, if the output is low, it is very close to 0 volts. But if the output is high, it is very close to the supply voltage which we placed on pin number 8. Now, this output pin that we are talking about is where you would connect the load that you want the 555 timer to power. Okay. Now, pin number 4. The pin number 4 on the 555 timer is the reset pin. Now, this pin can be used to restart or reset the 555 timer. Now, this is an active low input, just like the trigger input. So, the pin number 4 is basically connected to the supply voltage of the 555 timer. If it's even momentarily connected to ground, the 555 timer would stop operation, and it would not start again till it's triggered again via the pin number 2. Now, pin number 5 is the control pin on the 555 timer. Now, most often what people do is this pin is simply connected to ground, usually through a small capacitor, about 0.01 microfarad. Now, this capacitor is put in there just to clean out any fluctuation in the power supply voltage, because if there is a fluctuation in the power, that might affect the operation of the chip. Now we come to pin number 6. Now, the pin number 6 on the 555 timer IC is called the threshold pin. Now, what this pin actually does is it monitors the voltage across a capacitor which is discharged by pin number 7. Now, whenever the voltage across this capacitor that's discharged by pin number 7 reaches 2/3 of the supply voltage, the timing cycle is ended and the output on the pin is made to go low. So moving to pin number 7. Now, the pin number 7 is the discharge pin. Now, this pin is used to discharge an external capacitor that works in combination with the resistor to control the timing intervals. Now, most often in circuits, pin number 7 is just connected to the VCC, the supply voltage. through a resistor and to ground through a capacitor. Pin number 8 is where we would connect your power supply. Now the range that the voltage needs to be anywhere between 4.5 volts at the minimum and 15 volts at the maximum. And this needs to be DC voltage. We had spoken about a variant of the 555 timer chip, which is called the 556. Now, essentially, what the 556 is two independent 555 timers built into one package. Now, if you see the image on the screen right now, this is an image of a 556 timer chip. Now, depends on the left, which is labeled in green. Those would be one 555 timer chip, and the pins labeled in purple on the right would be a second 555 timer chip. Now they are totally independent of each other. The only thing that they share is the ground rail and the power supply. Otherwise, they are two totally completely independent 555 timers. Now let's look at the block diagram of the internals of a typical 555 timer chip. Do you notice those three 5K resistors? Incidentally, because there are three 5K resistors, that is how this IC got its name, the 555. Okay, so now let's look at the three main or most common operating modes for the 555 timer. One is the astable mode. The second operating mode is called the monostable mode, and the third one is called the bistable mode. And let's look at these each of them in detail. Okay, so we'll first discuss the astable mode. Now it is called the astable mode because it does not have any stable state. The output of the 555 timer continuously switches between highs and lows without any interaction or intervention from the user or any other circuit. The output, as has mentioned before, is square wave. Now, the application of this type of circuit would be if you want to have flashing lights to switch on and off, or if you want to have motors and some other equipment that turns on and off at regular intervals. This would be the type of circuit that you would want to use. And also in electronics, in computers and electronic circuits, they are also used to provide what's known as a clock pulse. Okay. The circuit to set up the 555 timer in the astable mode would have two resistors and two capacitors. And one of those capacitors would be a 0.01 microfarad capacitor. The second capacitor and the two resistors would be calculated depending on what the high time is and the low time is, and what frequency you want it to generate, and what the duty cycle would be. The formulas are given on the screen right now. Now let's look at the monostable circuit. Now a monostable circuit produces one pulse. Okay, one pulse of a set length or set duration. The output pulse is generated when there is a trigger. Now this can be a push button or any other trigger, but the pulse that is generated is as a result of there being a trigger. Till there is a trigger, the output remains low, but when there's a trigger, the output goes high, and it stays high for a specific period of time. Now this could be used to turn something on for a specific amount of time. So those are the type of uses of a monostable circuit. The circuit for setting up the 555 timer integrated circuit in a monostable mode would have two capacitors and one resistor. One capacitor, like the earlier circuit, would be a 0.01 microfarad. The other two components, one capacitor and one resistor, would be calculated using the formula that's shown on the screen right now. Here what we can do is by changing the value of R1 and C1, we can have the circuit have different timer delays, and those delays would be in seconds. We are going to be looking at the bistable setup for the 555 timer. Now, bistable mode has basically two stable states, the high and the low. Now, the output goes high when it is triggered and goes low when it's reset. Now, the trigger input and the reset input are active low. What that means is, now taking the trigger input low makes the output go into the high state, because since the trigger is a low active low, it activates the circuit when it goes low. So when you put the trigger low, it activates the output to go high. Now the reset signal is also active low, which means when you take the reset input low, it makes the output go low also. And the application or the use of this kind of circuit would be to start and stop a certain mechanism at after a fixed duration, right? The circuit for setting up the 555 timer in the bistable mode would have two resistors and a capacitor. The capacitor would be a 0.01 microfarad, and resistors are just to limit the current. Now it will have two push buttons or switches, the trigger switch and the reset switch. Now when the trigger button is pressed, the trigger input is grounded, and so it goes low. When the trigger input goes low, the output goes high, because the trigger is low active. Now when the reset button is pressed, the reset input is grounded, and so it goes low. And since the reset input is also active low, when the reset is grounded, the output also goes low. And with that, we come to the end of this video. If you like this video, please kindly give it a thumbs up, and please also leave your comments in the comment section down below. And if you'd like to see more videos like this, please also subscribe and make sure you hit that bell icon, so you always receive updates when new videos are uploaded. Thank you.